Much of our modern mathematics was developed by a man by the name of Descartes, and he put together what we call the Cartesian plane, from which we get rectangular coordinates. And the rectangular coordinates that we get are of the form xy. It turns out that xy plane is not the only type of mathematical representation for plotting points and relationships and functions. There are other ways to do it, and other ways that are more useful in other applications in the real world, especially within physics and engineering and things of that nature. This one will be a representation of polar coordinates instead of rectangular coordinates. And a polar coordinate does not have labels of x and y, but rather r and theta. Anybody want to guess what r stands for? Radius. Radius, and theta is an angle, and thus the connection within trigonometry. So what we would like to do today is we would like to be able to plot polar coordinates and try to rename some polar coordinates. Okay? And so I'm going to first label my graph. I'm going to call this 0 radians. And at the top here, I'll call it pi over 2. Obviously, the middle is going to be pi over 4. Do you guys remember what the other two marks are?
Pi over 6 and pi over 3.
Good. Pi over 6 and pi over 3. And then as we continue to go around, we have 2 pi over 3. We have 3 pi over 4. We have 5 pi over 6. For some of you, this is coming a little bit more quickly as you go through this process. So there's you, it's taking a little while longer. So that might depend on how well you did on some of these tests. If you need to review this, yep, making the unit circle would be a helpful piece to go through again. We good? Okay, so what we would like to do is plot the point 3 pi over 4. This is our r value, this is our theta value. Now, your mind will automatically go to the r value right away. Please refrain. Please go to the theta value first every time. That will help you out. So how I plot this is I rotate pi over 4 units. And then as I rotate pi over 4, I move 3 in that direction towards that angle. So 1, 2, 3. And that's the coordinate. Are we okay with that? All right, we're going to do another one. I'm going to plot the coordinate 4, negative 2 pi over 3. What's different about this one is the angle is negative. So what do I do for a negative angle? Rotate the other direction, okay? So you can see that positive 2 pi over 3 brings me right there. But I'm supposed to rotate negative 2 pi over 3. Which spot will it bring me if I rotate negative 2 pi over 3? Yeah, it's going to bring me to this 4 pi over 3. And then I move 4 units in that direction. 1, 2, 3, 4. Now we're going to get a little bit tricky here. I'm going to plot negative 5, 11 pi over 6. Does that look a little bit scary? We first rotate 11 pi over 6, which obviously brings us right out to this spot right here. Are we okay with that? Now the difference is the radius is negative. If the radius is negative, that means instead of traveling in the direction of that angle, I travel in the opposite direction. So 11 pi over 6, negative 5, I turn to 11 pi over 6, and instead of going 5 units that direction, I go 1, 2, 3, 4, 5. I go 5 units in the opposite direction. That's that language. Okay. And finally, what if we tried this? What if we tried -2 and -pi/2? See if on your own you can come up with the location for -2, -pi/2. Plot that. Check with the person next to you. How did they plot it? Is yours the same? -pi/2 brings me down here, and -2 I move the opposite direction, so that should be the location. You okay with that?
What's the correlation? It's just like when I see 4 different ways, I would have thought they all would have been like.
So to be clear, I didn't just do this.
Oh.
I just plotted 4 points.
All right.
I decided to change modes. So now we will go through the process of renaming them after you plot them. Go ahead and plot the first one. Plot the first. Hey. Plot the first one here, the second one here, the third one here, and the fourth one over here. Go ahead and plot them. Let's see if you can get those correct in your positioning. Everybody okay with those locations? Any questions how I got any of those locations? Okay, then what we want to do with each one is we want to rename it so it has another positive radius and another negative radius. We do one where it has a positive and one where it has a negative, okay? So notice in this location right here, okay, the angle ended up being over at 3pi/4, okay? I would like to maintain +1, but I want another angle that can bring me to the same spot. Can somebody think of another angle that can bring me to the same spot as 3pi/4?
7pi/4.
7pi/4 will bring me exactly to the opposite side.
-5pi. Oh, yeah.
-5pi/4. Notice -1pi/4, 2, 3, 4, 5. -5pi/4 is accurate. Now, somebody in third hour said, well, Mr. Gens, could you also just go around more than once? So they said take 3pi/4 and add 2 pi to it, or 8pi/4. And they said that they found 11pi/4. Yes, they are correct. 11pi/4 would also work. There's an infinite number of points that could be renamed for each point. Now look at the next one, -1. So if it's -1, I don't want to end up at 3pi/4 my rotation. I want to end up where Nevaeh said. I want to end up on the opposite side. So I could turn 7pi/4 and then go -1 or 1 unit in the opposite direction. You see that? Or I could go, instead of 7pi/4, what angle could you turn instead of 7pi/4 that would bring you to that same spot? -1pi/4. So you can see we've actually renamed this now 4 times. Go ahead, try the next one. It is 3 and then -3. So we're going to use a positive radius and a negative radius. A positive and a negative. See if you can rename it. Somebody else do something different?
Did negative 13 pi over 6 on the bottom.
Okay. Negative 13 pi over 6. For this one?
Yeah. Does that not work?
Wouldn't it be positive? Positive one?
So negative 13 pi over 6, I believe, works here.
Yeah.
If you
Oh,
traveled
yeah,
negative
sorry.
13 pi over 6, that would bring you right here. And then you would want to move 3 units in that direction.
Okay. I was thinking positive. I think.
See that?
Yeah.
Could you do negative 7 pi over 6 for the top one?
If you did negative 7 pi over 6, negative 7 pi over 6 will bring you right here.
Oh, yeah.
And then you need to go negative 3. So negative 7 pi over 6 would work for the bottom.
Okay.
See that now?
Mm-hmm.
Okay, the next one, the first one is nice and simple. Anybody see what I compare with 3 to get that spot right away? 0. Yeah, that's it. And then negative 3, see if you can do that one on your own. Negative 3, what would be your option then to pair with negative 3? So we want to rotate to this side or like that. So the most common answers are either positive pi or negative pi. Either one would be fine. Good there? All right, last example. So we're going to have a positive 4 and we're going to have a negative 4. I'm going to do the negative one with you. You do the positive one. What is a angle that could position you at that spot such that you have a positive 4? Angle options would really be either 5 pi over 4 or negative 3 pi over 4. Either one would work. And if you're coming up with a negative 4, that means you want to be different than that pi over 4. So you still want to end up at this spot. I don't want to rotate pi over 4 because that's the one I've been given. So I'm going to rotate the other way, and that would be a negative 7 pi over 4. And that would be the location of our polar coordinates. So, where are you right now? If you would look at your homework, all we have scratched is really just kind of that first problem. And there's not a lot that we want to do to spend on polar coordinates. We just really want to spend 2 days, that's it. And this was really one of them. But if you notice the graph that I give you, I apologize, it's got some extra lines in it. So notice on the graph that I gave you on your sheet here, it first starts at pi over 6. Yours actually starts at pi over 12. You got that extra line in there, see that? So you can ignore the extra line towards the axes. You guys see what I'm saying? Like in between each one, you've got 1, 2, 3, 4, you got 5 markings. You could just use the inner 3. And that should help you out. And that's that.